So in this section, simplify radicals. The purpose of simplifying radicals is mainly to write in simple terms. In addition to that, when we write in simple terms, there's the possibility if we can add or subtract them. We're not going to focus on multiplying or dividing, but mainly just writing in simple terms and adding and subtracting them if possible. So radical means with roots. So our first example, let's say we're simplifying the square root of 20. So the square root of 20, if we want to write in simple terms, and the reason we don't have to worry about add or subtract is because there's no plus or minus with another term. We're just simplifying this. Now, when it comes to simplifying radical terms, especially with square roots, since it's square root, we have to remember our perfect square. So I'm going to write on this side. So 1 square is just 1. 2 square is 4. 3 square is 9. 4 square is 16. 5 square is 25. 6 square is 36. 7 square is 49. And so on. So you get the main point. Now these squares, these perfect squares, when I'm simplifying radicals, mainly I'm going to focus on this 1, this 4, 9, 16, 25, 36, and 49, and so on. The reason is, when we get into these perfect square numbers, we're able to apply the square root. But the 20 does not match with any of the perfect squares. So what happened is, we're going to break it down. So we're going to break it down right here. Break it into factors. So we're going to break it into factors. So the square root of 20 here we're going to break it into two factors. So one of them has to be a perfect square number. So one of the ones that I underline here. Now we could use 1, but 1 times 20, you're going to result to be in the same position as before, so we're not going to use that. But what we could use is 4, because 4 times 5 will equal to 20. There's no other higher perfect square numbers that will multiply into 20, so we're safe to use 4. So I can break I break 20 into 4 times 5, so I'm going to write 4 times 5 with one big square root. Now, since it's multiplying, I can actually break it into 2 square roots. So I'm going to write the square root of 4 times the square root of 5. At this point, one of them is a perfect square number, which is the 4. So apply square root. In this case, this one right here. So we have a perfect square number. We can apply the square root. So the square root of 4 is 2. Bring down the multiplication sign. I can't simplify the square root of 5 because I cannot break it down into factors where one of them is a perfect square number besides 1, and I cannot do the square root of 5 because it's not a perfect square number, so I'm just going to bring it down. So the square root of 5, and then I apply 2 times square root of 5, so it's going to be 2 square root of 5. So that's our answer for our first example. Now, when we're dealing with simplifying square roots, step 1 is break into factors, and then once you break it down, basically separate and then apply square root. So those basically are steps. So here I should wrote separate factors. So step 1, break into factors. Step 2, separate factors. Step 3, apply square root. So here's the steps on simplifying square root of 20. Now, when you're simplifying radicals, you don't have to worry about plus and minus. Just simplify. So if it asks you to simplify square root of 20, you break it down to 4 and 5, and then you have square root of 4 times square root of 5. If it asks you to do the square root of the number, just write 2, don't worry about plus or minus. Now, in this second example, I wrote the square root of 32 twice. Now, the reason is, simplifying radicals seem fairly easy. Now, when it comes to this particular topic, there's going to be problems where there's multiple ways of simplifying. So here I wrote it twice because there's actually 2 ways. But I'm going to talk about which way is faster, so that way it's going to be less confusing and save you time. Now, simplifying the square root of 30. So if I were to look at these, your first thought is you could use 4 and 8 for 32. So let's do that. So 4 times 8. So I have the square root of 4 times 8, so I'm going to break it down. Now, I can apply the square root of 4, which is 2. But also, you can break the 8, because 4 is a factor of 8. So I'm going to rewrite it as 4 times 2. The 4 times 2 is for that 8, and the 2 is the square root of 4. Now, I'm going to bring down the 2, and then I'm going to repeat the same step, so we'll break this into 2 factors. So square root of 4 times square root of 2. And then, I can do the square root of 4, which is 2. And then I bring down everything else. Doing so, I simplify into its simplest form, and then square root of 2, you can't simplify that. So that's going to be 2 times 2, which is 4, and then carry the square root of 2. So that's all we can do. So 4 square root of 2. So to review, we broke up the 32 into 2 factors, 4 times 8. Then I split it into 2 radicals, 2 square roots. So square root of 4 times square root of 8. I was able to simplify square root of 4, which is 2. And then here, square root of 8, we can continue to break it down into 2 factors because 4 can be a factor. And then I separate the 2 factors while I'll bring down the 2. So now here we have square root of 4 times square root of 2. At this point, we can do the square root of it, which is 2. So I'll bring down the 2. I did the square root of 4, which is 2. I bring down square root of 2 to here, and then I multiply. So 2 times 2 is 4. 4 times square root of 2 is just 4 square root of 2. Now, to go to this part, the reason I decided to write is because besides 4, there's another one, another perfect square number we can use. In this case, we can use 16. So if I decide to use 16, I can break it into two factors of 16 times 2. And then square root. So square root of 32 can be broken down to 16 times 2. Now I'm going to separate it as two square roots. So square root of 16 times square root of 2. So moving forward, you can find the square root of 16, which is just 4. Can't simplify it anymore for square root of 2, so I'm just going to bring it down. Then 4 times square root of 2 is simply 4 square root of 2. So that's our answer. As you can see, they're both the same, even though we use different factors. But in this sense, it seems a lot better if we just use the easy or fewer steps. Should I say the easier method? So, in order to find the easier method to save yourself steps, to save yourself work, to save yourself time, I would say check. So check for higher perfect squares. So when I'm saying perfect square, I'm talking about the one that I underlined in red. So in this example, square root of 32, you could either use 4, let me underline that, or you could use 16. Now if you use 4, you do more steps, but if you use 16, you have fewer steps, save yourself some time. Now the reason I would recommend to find higher perfect squares is that it's easy to follow through. Now if you use a different number, it still works and still get you the same answer, but the issue here is sometimes you create more room to make errors, and then during your work, within your work, you may get confused, you don't know where to fix it, and you might want to start over by erasing the whole thing or give up. Now, if you don't want to be in that position, always ask yourself, check for higher perfect squares. Could any of them be used? This example, instead of using 4, I could use 16, save myself some time, save myself of more work, and less chance of making an error, as long as it's done correctly. Alright, so in example 3, we have 2 square root of 32s. So again, I am trying to show you multiple ways of solving it, simplifying, but there is a faster way if we find out which one to use. Now let's start off with the first 72. You can use 4 because 4 can go into 72. So 4 times 18 will equal to 72, and I'll break it down into two factors, two square roots, I mean. So 4 times square root of 18. So doing so, square root of 4 is 2, but you can break the 18 down because guess what? 9 is a perfect square and 9 can go at 18. So basically 9 times 2 inside a big square root. So I'll bring down the 2 and the multiplication sign, and I could break this into 2 square roots. So 9, the square root of 9 times the square root of 2. Then I can continue because we can apply the square root of 9, which is 3. Bring down the 2, multiplication, multiplication, bring down the square root of 2. And then as I continue working, there's nothing else I can simplify here, nor here, nor here. So I'm just going to multiply. So 2 times 3 is 6 times the square root of 2. And that's our answer. So the square root of 72 is 6 square root of 2. Now, there's an easier method. Besides 4 and 9, was there another perfect square? Let me re-explain, rephrase it. Is there a higher perfect square we could use besides 4 and 9? Yes, there is. We can use 36. So if I were to use 36, I could break 72 into 36 times 2. So 36 times 2 will equal to 72. So let's break it into 2 square roots. So 36 times square root of 2. Then the only one I can simplify is the square root of 36, which is 6. Bring down the multiplication sign, bring down the square root of 2. Then the only thing I can do is multiply, so 6 times square root of 2 is just 6 square root of 2. That's it. That's all I can do. So that's our answer. So as you can see, over here if I use 4, I can break up the 18 into 9 and 2 and do more steps. But over here, I use 36 because it was a higher perfect square. So 36 times 2 broke it down into 2 factors. And then I was able to simplify square root of 36 into 6, multiply, and get the answer 6 square root of 2. And as you can see, the two answers are the same. So in the first process, I did step 1, step 2, step 3, step 4, step 5, and then the answer. So 5 steps. Over here, I did step 1, step 2, step 3, and then the answer. So basically 3 steps. So always check if you can use a higher perfect square. If you can, then you save yourself some time and work and less chance of errors. Now, if you want to check on which one you can use, always write it out using your multiplication table. Okay?